Hi everybody, welcome to sections 2.3 and 2.4, your voiceover video over accompaniment to these sections. So let me again move myself down so I don't cover the copy. So what we're going to do now that we've learned what a scaling factor is we're going to scale a recipe based on either the recipe quantity or a constraining quantity. And then we are going to learn what it means to standardize a recipe. So in this case, we have a recipe for coconut macaroons, and our goal is to use up 425 grams of shredded coconut. So you'll also see that on these PowerPoints, you'll see a little speaker icon in the middle. If you don't want to go through and listen to or watch the video, I also narrate on that little speaker icon. So you got lots of options. So in this case, we see the recipe there, right? I want you to get real familiar as you're learning about scaling. So up here at the top of a recipe card is going to be the recipe name. Next, it'll either say makes or yield. Those are synonyms to tell you how much you'll end up with after you fabricate the entire recipe. So make and yield are synonyms, and this recipe makes 20 dozen cookies. And remember, there are 12 in a dozen, so you'd have to do 20 times 12 to find out how many cookies that is altogether. This is the list of ingredients here. So in word problems in this section, if you see the words calls for, that's going to come on your recipe list here. That's going to come from the ingredient list. So let's see, our goal is to use up 425 grams. Well, this recipe calls for 3 pounds. So we know that we're coming up with a scaling factor based on constraining ingredient or the amount of an ingredient we want to use. And remember, it could be that we want to use more of an ingredient or less than an ingredient. Right now, since we don't really speak gram and pound that fluently, we're not really sure which one is more, but we can find out. So the next step, let me move myself again up here. The next step that we have to do is we have to figure out, and we're going to do that down here, we can't divide pounds by grams. We have to get them both to the same. So in this case, down here, they're going to help us convert the 3 pounds that the recipe calls for to a number of grams, okay? And when they do that, when they convert or do a bridge from 3 pounds to grams, they're probably using the steps pounds to ounces, ounces to grams, and then they come up with the amount of grams that 3 pounds is. And when they did that, they calculated that 3 pounds is also 1,360.8 grams. Now our job is to plug it into the scaling factor formula. Scaling factor is constrained ingredient, the amount you want to use, 425 grams, divided by the recipe quantity. And where, again, did we get this recipe quantity? Well, it was right here, 3 pounds, but we can't divide grams by pounds, so we converted 3 pounds to this many grams. When we do that, we get a scaling factor of 0.312. Then to scale simply means to multiply everything in the recipe by our scaling factor, right? So because we got a scaling factor of less than 1, that means we're making less and we're using less, right? We're using less coconut, and we want all these other ingredients to be in perfect relationship with the 425 grams that we're using. So we multiply by our scaling factor and we get all these new quantities, okay? So you can look at butternut squash soup and you can follow that example in your book, and then you can determine the scaling factor and multiply every item in the recipe by that scaling factor. Let's move on to 2.4. Now what we're going to do in this section is we're going to introduce the term standardized recipe, and we're also going to introduce the term sub-recipe. So this combines recipe scaling and unit conversions, which I warned you in the beginning, you will never stop converting and never stop using the bridge. So oftentimes professional kitchens will come up with their own standard. If you watched the Instagram message that I posted last week from Chef Thomas Keller, he was giving you a recipe on Instagram for his buttermilk dressing base. And as he was rattling off all the ingredients, he was rattling them all off by metric weight. What that told me is that the standard in his kitchen is metric weight. So he believes that is the most efficient way to measure, and he thinks that it's the most accurate. So his recipes will all be written by the standard of metric weight. That's how you'll read it. Maybe some of you are pastry chefs, and in your kitchen, you will use U.S. customary volume because you just prefer that. So all your recipes would be standardized to U.S. volume. What does that mean for Chef Keller? Well, if he came to work from you, he'd have to standardize his metric weight recipes to your standard, which is U.S. volume. It's also important to note that some chefs can opt to use non-standard units of measurement. What do I mean by that? Well, I said that Chef Keller might use gram and kilogram. Those are his standards. Our student who I said might own a bakery might use U.S. volume standards. So he or she might be using teaspoon, tablespoon, cup, quart, and so on. Okay? But sometimes a chef might write a recipe by a non-standard unit that we refer to as eaches. Okay? Another one might be bunches or cloves. Basically, instead of using a unit of volume or weight to tell us how much of an ingredient, we're going to use one of these measures of eaches. Okay, and each or eaches is not really a proper word in the United States, but it is very commonly used in professional kitchens. So think about it. On a recipe for a cookie, it might say eggs 4 eaches. Eaches mean for each of the egg that we mentioned. A recipe for tomato sauce might say 4 cloves of garlic. It doesn't tell us to measure the garlic by weight or volume. It tells you to go get 4 cloves. You could see a recipe that might say apples, 12 eaches. That just means you want 12 apples. So you may see these on a recipe. Don't get discouraged, but if we're looking to convert these non-standard units, we might have to go find the weight of an each, right? So we have done recipes or ingredient conversions so far. We've done garlic, right? And we've seen 2 pieces of information to help us go from eaches to weight. So if you turn back in the Book of Yields, and maybe you should do that right now to get familiar, go find garlic. And I think if I remember correctly, you'll see that a head of garlic, right, or a bulb, you might call it, one of those big, the way you buy garlic at the farmer's market, a head or a bulb, that weighs 2.1 ounces on average, okay? And on average, inside a head of garlic, there are on average 12 cloves or eaches. So you could figure out how many ounces 7 cloves of garlic weighs by going back to the Book of Yields and finding out that information, that one head weighs 2.1 ounces and that on average there are 12 cloves in a head. So there's an example on page 63 for grilled chicken with mango, red onion, and pineapple. And if you take your book here that we all have and turn to page 63, you will see that we are asked to standardize the recipe below to yield 32 servings. Well, if we scroll down, let's see, the recipe says grilled chicken with mango, red onion, and pineapple yields how many? It says 4. Okay, so we need to standardize to yield 32. So you'll see there, it gave us the formula for scaling factor based on desired yield, and that's desired yield divided by current recipe yield. So 32 divided by 4 gave us the 8 servings. Okay, so then we go down, we determine that scaling factor, and then we can multiply everything on page 64 by the scaling factor that we calculated, which was 8. Okay, so you can see the scaled recipe, what they called for. The first column on page 64 says ingredient, then they're all listed. Then it said recipe quantity, then it says scaling factor, and you multiply by 8, And then the final column says scaled recipe quantity, and you can see there what the new quantities are in order to have 32 servings and not 4, because we multiplied all these ingredients by our scaling factor of 8. Okay, so there's another example of standardizing a recipe on page 64 and 65. It gives us the same recipe for chocolate chunk cookies, but one example tells us to standardize it to US pounds. So you'll see that you'll see the recipe on page 64. Then you'll see the conversion from all the way that it's listed, and it's listed, mostly the ingredients are listed by US volume, and then you'll see how they standardized or converted everything in this recipe to US pound. They must use a pound scale. Then if you flip the page to page 66, we must now be taking this recipe to go work for Chef Keller, because now we are asked to standardize the same chocolate chip cookie recipe to use on a metric scale that is accurate to 1 gram. So now we are converting all of these US quantities for chocolate chip cookies from US volume, you'll see there in that second column named recipe quantity, to the new standard. And in this kitchen, which we can assume might be Chef Keller's, we're going to standardize all these ingredients to grams or kilograms. Okay, so we will never stop using the Book of Yields. I told you about that in the beginning. We will never stop using the bridge. So as needed, use the Book of Yields to help you out if you need to convert. But these pages are going to be great resources to watch how those conversions will happen. Okay, so the next and final thing that I want to discuss with you is a new term called a sub-recipe. So I want you to look on page 67 at the recipe for ancho chili crusted salmon with yellow mole. Now at the top you'll see that recipe, and it'll say yields 25 servings. Then it'll list all the ingredients. Then you'll see a sub recipe for yellow mole. What a sub recipe means by definition, it's just a recipe that you always make to go along with the big recipe. So this salmon is always served with the yellow mole sauce. If we're switching to a pastry kitchen, maybe you're making a raspberry tart with a creme anglaise. So every time you make the raspberry tart, you're going to need a creme anglaise to go along with it. And, you know, if you're making 8 slices out of 1 tart, that's great. You might need, 16 fluid ounces. Maybe you give 2 fluid ounces per serving. But what if you're doing this for a wedding and now you need 12 tarts? Well, that one recipe, sub-recipe for creme anglaise, will only make 16 fluid ounces. So now you need to scale that because your bigger recipe needs to make more. So let's take that example and look. The ancho chili crusted salmon will, if you scroll down through the entire ingredient list, it needs 50 fluid ounces of yellow mole in order to make these 25 servings. Well, look at the yellow mole recipe. How many does that make? 32 fluid ounces. So we won't have enough. So turn to page 68 and you'll see there that now they're determining a scaling factor for this sub recipe based on desired yield. We need 50 fluid ounces divided by the 32 fluid ounces that this mole sauce calls for. So when we plug that in, we get a scaling factor of 1.5625. Now our job that you see in the example here is to scale everything for this yellow mole times our scaling factor and then to standardize it to US weight. So we're combining a couple steps here. We're coming up with a scaling factor. We're learning what a sub-recipe is. We're scaling, and now we're standardizing, because this yellow mole, there's all sorts of units in here. There's ounces, there's teaspoons, there's pounds. So it's a lot of different US volume and weight, but apparently our standard for this kitchen is US weight. So we need to standardize all of these quantities once we scale them to either ounce or pounds. And you see a great example there how to do it. So go through and work on all the problems in all these sections that are assigned to you in week 3. If you have any questions, reach out. Otherwise, I will see you in Zoom and in the classroom. Have a great week.